Hello dear students, in this video I will continue with Unit 5 Inferential Statistics, and in this video I will solve those questions of one sample t-test from exercise 21.1 of chapter 1 Inferential Statistics Applied Mathematics by D Sharma. In my previous video I have explained about one sample t-test, and in this one sample t-test we have to calculate the t-test statistic. And here is a recap of how to calculate t. Let x1, x2 up to etc. xn be a random sample of size n from a normal population with mean mu and variance sigma square. Then student's t statistic, it is given by t is equal to x bar minus mu upon s by root n, where x bar is the sample mean. Summation I is equal to 1 to n xi upon small n, that is the sample size, and s square, it is the unbiased estimator of population variance. It is given by 1 by n minus 1 summation I equal to 1 to n xi minus x bar the whole square. Now we usually calculate variance as 1 by n summation I equal to 1 to n xi minus x bar the whole square. But here we have this capital S square as 1 by n minus 1 summation I equal to 1 to n xi minus x bar the whole square. Now here we will see how we can find t when the sample variance is given. Now the sample variance is denoted by small s square. Sample variance small s square, it is equal to 1 by n summation I equal to 1 to n xi minus x bar the whole square. Now if this small s square is given, then we will see how we can find the test statistic t. So from here we can write this as n into s square equal to summation I equal to 1 to n xi minus x bar the whole square. If we take this as 1, here 1 implies summation I equal to 1 to n xi minus x bar the whole square, it is equal to n minus 1 into s square. So let us mark this as 2. So this implies n s square equal to n minus 1 into capital S square. This is from 2. So we have s square upon n minus 1 equal to capital S square upon n. This implies small s by root n minus 1 equal to capital S by root n. So in place of capital S upon root n, we can put small s upon root n minus 1. Therefore, we have another relation for t which uses this sample standard deviation small s. So t is equal to x bar minus mu upon small s divided by root of n minus 1. So if we are given summation I equal to 1 to n xi minus x bar the whole square, if this value alone is given, then we can use capital S square using this relation. On the other hand, if we are given the sample variance small s square, then we can use t as x bar minus mu upon small s, that is the sample standard deviation upon root n minus 1. So here we have another relation for the t-test statistic. Now moving on to the problems. A small recap of the steps that should be followed. The first step is writing the hypothesis, null hypothesis and alternative hypothesis. Then the second step is calculating the t value. Then the third step is comparing the calculated value with the table value. The fourth step is making a decision whether to accept or reject H0. That is the fourth step. And then the last step is we have to summarize the result. So the last step is the result. So these are the steps involved in one sample t-test. Now coming to the exercise questions. The first one. So here it is given a random sample of 10 cartons are taken, and then the mean weight of the cartons is 11.8 kg and the standard deviation is 0.15 kg. We are asked to check whether the sample mean differs significantly from the intended weight of 12 kg. So here the population mean is 12 kg. We have to check whether there is significant difference between this sample mean and this population mean based on the sample mean 11.8 kg and the standard deviation 0.15 kg, which is given here. Here they have directly given the table value. Here there are 10 cartons. So the number of degrees of freedom will be 10 minus 1, which is 9. So the tabulated value for T at 5% level of significance with 9 degrees of freedom, it is equal to 2.262. So this they have given directly. So we need not check the tables. So first we will write what is given. So here it is given the mean net weight of the cartons is 11.8 kg. It means the sample mean x bar is given 11.8 kg. And then the standard deviation is 0.15 kg. Here the sample standard deviation small s is given, which is 0.15 kg. And we have to see whether the sample mean differs significantly from the intended weight of 12 kg. It means 12 kg is the population mean. So the population mean is 12 kg and the sample size is 10. So n equal to 10. The first step is we have to write the null hypothesis H0. There is no significant difference between sample mean and the population mean. And the alternative hypothesis is there is significant difference between sample mean and population mean. So here the test statistic, it is given by T is equal to x bar minus mu upon S by root of n minus 1. Since here we have only the sample standard deviation, so we need small s. So let us calculate T by substituting each of these values. So this is equal to 11.8 x bar minus mu is 12 upon s is 0.15 upon root of 10 minus 1. So this is equal to minus 0.2 upon 0.15 into root 9. Root 9 is 3. So we have 0.2 into 3 upon 0.15. So from this we get T equal to minus 4. Now since T is negative, we need to have mod T. Mod T is 4. Now we have to compare this mod T with this value at 5% level of significance and 9 degrees of freedom. Here we can see that this 4 is more than 2.262. So as a result, we have to reject H0. So the step 3, calculated mod T is greater than the tabulated T value. Tabulated value of T. Tabulated value of T is nothing but it is 2.262. So we have the conclusion. So the step 4 is the null hypothesis is rejected at 5% level of significance. So on the last step we have the result, fifth step, it means the sample mean differs significantly from the intended weight of 12 kg. So the last step, hence the sample mean significantly differ from the intended weight of 12 kg. The meaning is that mu is not equal to 12. We took H naught as mu equal to 12 and we have to reject the null hypothesis. So it means the sample mean significantly differ from the population mean. We took x bar equal to mu. There is no significant difference between sample mean and the population mean. But since we have to reject H naught, we have the sample mean differ significantly from the intended weight of 12 kg. Moving on to the next question. A machine is designed to produce insulating washers for electrical devices of average thickness of 0.025. A random sample of 10 washers was found to have an average thickness of 0.024 with a standard deviation of 0.002. Test the significance of deviation given table value of t at 5% level of significance with 9 degrees of freedom is 2.262. So here a machine is designed to produce washers for electrical devices with an average thickness of 0.025 centimeter. A random sample of 10 washers, it was found to have an average thickness of 0.024 centimeter and standard deviation of 0.002 centimeter. Now we need to test the significance of this deviation, whether the sample mean is significantly different from the population mean. So here it is given. The sample mean x bar is 0.024 centimeter. The sample standard deviation S is 0.002 centimeter. The population mean is 0.025 centimeter. And the sample size is 10. There are 10 washers which are taken as sample. N is equal to 10. So all these information is given in this question. Now we need to test the significance. The first step is null hypothesis H naught. There is no significant difference between sample mean and population mean. Then we have the alternate hypothesis H1. There is significant difference between sample mean and population mean. It is important that all these steps should be written for each of the question. And moving on to the next step, step 2. The test statistic is given by, here we have got small s. So t is equal to x bar minus mu upon s by root of n minus 1, or it is equal to x bar minus mu into root of n minus 1 upon s. Now we can substitute each of these values. X bar is 0.024 minus mu is 0.025 upon s is 0.002 into root of n minus 1 is 10 minus 1. So this is equal to minus 0.001 upon 0.002 into root 9 is 3. So this is equal to minus 1.5. Now we need to have the modulus value. So mod t equal to 1.5. Now here we can see that the calculated value t 1.5 is less than the tabulated value of t 2.262. So it means we can accept H naught and there is no significant difference between the sample mean and the population mean. It means the deviation of 0.024 centimeter, it is not significant. Then we have step 3, mod t less than tabulated value of t. That is 2.262. So finally we have step 4 and step 5. So the fourth step is the null hypothesis is accepted at 5% level of significance. And finally, the conclusion, there is no significant difference between the sample mean and the population mean. Or in other words, we can write the deviation is not significant. Or we can write deviation is not significant. Moving on to the next question. A random sample of size 25 from a normal population has mean 47.5 and standard deviation 8.4. Does this information refute the claim that the mean of the population is 42? And here it is given the tabulated value of t at 5% level of significance with 24 degrees of freedom, it is 2.06. So here it is given a random sample of size 25 is having a mean of 47.5 and standard deviation of 8.4. Now we have to check whether there is any significant deviation from the population mean of 42. So first let us write given n equal to 25, x bar equal to 47.5, that is the sample mean. Small s, the sample standard deviation is 8.4 and the population mean is 42. So all these are given in the question. The first step is we have to write the null hypothesis and the alternate hypothesis. The null hypothesis, the sample was drawn from a population with mean 42. So here, does this information refute the claim that the mean of the population is 42? So we take the null hypothesis as the sample was drawn from population with mean 42 and the alternate hypothesis is the population mean is not 42. The next step, step 2, the test statistic is given by t equal to x bar minus mu upon s by root of n minus 1, or it is x bar minus mu upon s into root of n minus 1. Now x bar we know it is 47.5, mu is 42 it is given and s is given as 8.4. Root of n minus 1 is root of 25 minus 1. So this is equal to 5.5 upon 8.4 into root 24. Root 24 is approximately equal to 4.89. So when we simplify, we get this as 3.2. So the calculated value of t, it is equal to 3.2. Now this 3.2, it is greater than 2.06. It means we have to reject H0 and we conclude that this claim should be refuted. Refuted means we cannot agree. So we cannot agree to the information that the mean of the population is 42. So the third step is mod t greater than t 0.05 with 24 degrees of freedom. That is 3.2 greater than 2.06. As a result, the null hypothesis is rejected at 5% level of significance. And finally, we have the result, fifth step. Hence, the claim that the population mean is 42 is refuted. Refuted means it is not agreed. Next question. A process of marking certain bearings is under control if the diameter of the bearings have the mean 0.5 centimeter. What can we say about this process if a sample of 10 of these bearings has a mean diameter of 0.506 centimeter and standard deviation of 0.004 centimeter? Given T9 at 5% level of significance is 2.262. So here it is given the process of making certain bearings, it is under control if the diameter of the bearings, if the mean of the diameter is 0.5 centimeter. Now we have a sample of 10 bearings having mean diameter of 0.506 centimeter and standard deviation of 0.004 centimeter. We have to check whether this process is under control or not. So first let us write what is given. Given the population mean is 0.5 centimeter, then the sample size is 10. The sample mean is 0.506 centimeter and the sample standard deviation is 0.004 centimeter. So we have the null hypothesis H naught. That is, the process is under control. It means there is no significant difference between this sample mean x bar and this population mean mu. So we assume that the process is under control for null hypothesis H naught. Alternate hypothesis will be the process is not under control. Then the next step, the test statistic is given by T is equal to x bar minus mu upon S by root of n minus 1. So x bar is given 0.506, mu is 0.5 upon S is 0.004. Here I am writing into root of n minus 1. N is 10, so it is 10 minus 1. So this is equal to 0.006 upon 0.004 into root of 10 minus 1 is root 9, which is 3. So it is 18 by 4, which is 4.5. Now here we can see that the calculated value T is 4.5. This is greater than the tabulated value of T, which is 2.262. Now 4.5 greater than 2.262. Now let us write the third step. Step 3, mod T is greater than the tabulated value. So if it is greater than the table value, then we have to reject H naught. As a result, the process is not under control. So the fourth step is the null hypothesis is rejected at 5% level of significance. Hence, the alternate hypothesis will hold. As a result, the process is not under control. Next question, a machine is supposed to produce washers of mean thickness 0.12. A sample of 10 washers was found to have a mean thickness of 0.128 and standard deviation 0.008. Test whether the machine is working in proper order at 5% level of significance. Given table value of T at 5% level of significance with 9 degrees of freedom is 2.262. So here it is given a machine is supposed to produce washer of mean thickness 0.12 centimeter. So the population mean is 0.12 centimeter. A sample of 10 washers, it was found to have a mean thickness of 0.128 centimeter and standard deviation of 0.008 centimeter. We have to check whether the machine is working in proper order. That is, we have to check whether there is any significant difference between this mean 0.12 centimeter and the sample mean. So given population mean is 0.12 centimeter, sample size is 10, sample mean is 0.128 centimeter and sample standard deviation is 0.008 centimeter. All these are given. Now the first step is, let us write the null hypothesis H naught. The machine is working in proper order. The alternate hypothesis H1 will be the machine is not working in proper order. Null hypothesis H naught, it is nothing but there is no significant difference between the sample mean and the population mean. Whereas alternate hypothesis will be there is significant difference between the sample mean and the population mean. Now coming to step 2, the test statistic is given by T is equal to x bar minus mu upon S by root of n minus 1. X bar is 0.128, mu is 0.12 upon S is 0.008 upon root of n minus 1, let us bring it here, into root of n is 10, so 10 minus 1. So this is equal to 0.008 upon 0.008 into root 9 is 3. So the calculated value of the test statistic T is 3. Now this 3 is more than the tabulated value 2.262. 3 greater than 2.262. As a result, we have to reject H0. It means the machine is not working in proper order. So we have step 3. Mod T greater than tabulated value. So this means the null hypothesis is rejected at 5% level of significance, and the final conclusion is the machine is not working in proper order. So here we can say that the machine is working in proper order only when the mean thickness is 0.12 centimeter. Here we have found that there is significant difference between this population mean and this sample mean. As a result, the machine is not working in proper order. Next question. A random sample of 16 values from a normal population showed a mean of 41.5 and sum of squares of deviations from mean equal to 135. Can it be assumed that the mean of the population is 43.5? Given the table value, critical value of T at 1% level of significance and 15 degrees of freedom is 2.95. So here it is given a random sample of 16 values from a normal population. This sample showed a mean of 41.5 and sum of squares of deviations from mean as 135. Now we have to test whether it can be assumed that the mean of the population is 43.5 at 1% level of significance. So first let us write what is given. Given the sample size is given, and then the sample mean is given, n equal to 16, then sample mean is given 41.5, then the sum of the squares of deviations from the mean, it is 135, and the population mean 43.5. All these are given. Now we have to check the null hypothesis H0. Here H0 is mu equal to 43.5, and the alternate hypothesis is population mean mu is not equal to 43.5. So the test statistic is given by T is equal to x bar minus mu upon S by root n. Here we can use S because we are given the sum of the squares of deviations from the mean. So first let us calculate S. We know S square is equal to 1 by n minus 1 summation xi minus x bar the whole square. So it is 1 by n minus 1 is 16 minus 1 15 into this is given as 135. So this is equal to 9. From this we have S is equal to root 9, which is 3. So T is equal to x bar is 41.5, mu is 43.5 upon S is 3 upon root n is root 16. So this is equal to minus 2 by 3 into 4. So it is minus 2.67. Therefore, mod T equal to 2.67. So here we can see that the calculated value is less than the table value. 2.67 less than 2.95. So we can write the next step, step 3, mod t less than tabulated value. So as a result, we can accept H naught. Therefore, the null hypothesis is accepted at 1% level of significance. So the final decision is the mean of the population is 43.5. So here it is asked, can it be assumed that the mean of the population is 43.5? Since we have accepted H naught, the mean of the population is 43.5. Moving on to the next question. The mean weekly sales of chocolate bar in general stores was 146.3 bars per store. After an advertising, the mean weekly sales in 22 stores for typical week increased to 153.7 bars and showed a standard deviation of 17.2. Was the advertising campaign successful? Given table value of t at 5% level of significance at 21 degrees of freedom, it is 2.08. So here it is given the mean weekly sales of chocolate bar was 146.3 bars per store. After an advertising, the mean weekly sales in 22 stores, it was found to increase to 153.7 bars and a standard deviation of 17.2 was recorded. We have to check whether this mean is significant. That is, whether there is any significant difference between the mean of sales before the advertising campaign and the mean of sales after the advertising campaign. So given mu is 146.3, n is 22, x bar is 153.7 and s is 17.2. So initially it was 146.3, so that we have taken as population mean, and then n is 22, then the sample mean is 153.7 and the sample standard deviation is 17.2. Now we have to test whether this mean is significant. So the first step is the null hypothesis. Here we assume that this mean is not significant. That is, the mean before the advertising campaign and after the advertising campaign both are equal. That is what we have to assume for null hypothesis. So the null hypothesis H naught will be the advertising campaign was not successful. The alternate hypothesis H1 will be the advertising campaign was successful. Now the test statistic is given by t is equal to x bar minus mu upon here small s is given. So it is s upon root n minus 1, or it is x bar minus mu divided by s into root of n minus 1. So here x bar is 153.7 minus mu is 143 upon s is 17.2 into root of 22 minus 1. So this is equal to 7.4 upon 17.2 into root 21 is 4.58. Now this, when we simplify, we get this as 1.97. So here we get 1.97, which is smaller than the table value at 5% level of significance and 21 degrees of freedom. 1.97 less than 2.08. As a result, H naught is accepted, which means the advertising campaign was not successful. So we have the next step, step 3, mod t is less than the tabulated value. Therefore, the null hypothesis is accepted at 5% level of significance. Hence, the advertising campaign was not successful. Moving on to the next question. A random sample of size 20 from a normal population gives a sample mean of 42 and standard deviation of 6. Test the hypothesis that the population mean is 44. Given T19 at 5% level of significance is 2.09. So first let us write what is given. Sample size is given, and then sample mean is given as 42. Sample standard deviation small s, it is given as 6. We have to test the hypothesis that the population mean is 44. So mu is 44. So this is very easy. Null hypothesis, population mean is 44. Alternate hypothesis, population mean is not 44. So the test statistic is T is equal to x bar minus mu upon s by root of n minus 1. So it is 42 minus 44 upon 6 into root of 20 minus 1. So it is minus 2 by 6 into root 19, it is approximately 4.36. Now this when we simplify, we get minus 1.45. So from this we have mod t is equal to 1.45. So here we can see that the calculated value of t is less than the table value 2.09. 1.45 less than 2.09. It means we can accept H0. Therefore, the population mean is 44. So, the next step, mod t less than tabulated value. So, the null hypothesis is accepted at 5% level of significance. Hence, the population mean is 44. So, this is how we have to solve each of the question, that is we have to test each of the hypothesis stepwise by writing the first step is hypothesis, second step is test statistic, and then the third step is we have to compare the calculated value of t with the table value, and finally we have to accept or reject H0. Now based on the decision of accepting or rejecting the null hypothesis, we have to write the result. I hope this video was useful for you. In my next video, I'll solve questions when the sample observations are given. Thank you for watching.